The BFS algorithm, Breadth First Search. In this episode, we are going to discuss the BFS algorithm. So let's say you need to go to a party, a great one, at the end of the city, and you have decided with your friends that you're going to order a bus that will pick up everyone and will drive to the end of the city. So the way you plan to do this for the bus, you tell the driver, okay, first you take me, and then we are going to pick up all the friends around me, basically all the neighbors. And then for each neighbor, we are going to pick up all its neighbors, and then for the next neighbor, we are going to pick up all its neighbors until we reach the end of the city. So basically the bus is going to pick you up, then pick up all of your nearest friends. Then for each friend going to pick up each of its nearest friends. And this is the way the BFS, Breadth First Search algorithm works. It's like a wave. Okay, it's like if suddenly the ocean has erupted from your building in a wave, this is the way the BFS works. So let's dive in and see how we would implement and what are the additional details on this BFS great algorithm. So as we said in the previous episode, then we have basic building blocks algorithms in a graph in which we basically take these basic building blocks algorithms and build upon them and solve more complex problems. So we said that the DFS is a basic building block algorithm used mainly for the shortest path. Why for the shortest path? Because it's shooting. It's like an arrow or a bullet, shooting for the longest path and trying to find, okay, the guy that you are looking for. So in the BFS, we said that we're moving forward in waves. We are picking up all our friends until we get to the party. The running time of the BFS is not surprisingly because we go through all the nodes and or all the vertices, depending how you name them. Then we go through them. So the running time is proportional to simply the number of vertices and edges that you have in the graph, because this is what we're going to do. We're going to simply scan the graph, one node after another. So basically it's a wide algorithm. You can think of the DFS as a depth algorithm and the breadth as a breadth algorithm. It's a wide algorithm. Okay, you need to imagine a wave. In the BFS we are going to use queue. And why do we use a queue? We use a queue because once the bus driver has decided that it needs to pick up a few people, then it needs to remember, we need to go to John, to Edri, to Jonathan, so I'm going to write them down in a queue. And then once I visit John, I'm going to write down all its neighbors. Okay, so I'm inserting them in the queue, but I don't need to visit them right now. I need to visit them after I pick up Edri and Jonathan. So I'm going to add them to the queue. So the main thing about utilizing a queue is that so you know to yourself, hey, after I pick up all my neighbors, then I need to go on and move on and pick up all the neighbors of the first person that I picked up. So the bus driver is picking up one neighbor, one friend after another, and for each friend that it's picking up, it's noting, it's like taking a note, and I need to take all its friends. But I will take them only after I took the previous friends, because they have a priority. So the queue is like placing, when you use a queue, it's a priority on the oldest. Okay, a stack is giving priority to the newest. The newest item is the one that you are going to visit, and the queue is giving priority to the oldest, because we are moving on in waves. So the important thing to remember is that we are going to use a queue. And then there is another important thing to remember in BFS. There are like two main points. One is the queue, and another one is that we mark again nodes as visited, or once we pick up a guy into the party, we mark that we visited him, because if by any chance we are going to get into this guy again, because you don't know how the edges are sorted out, okay? So if by any chance we are going to try and pick this guy again, if it's a friend of a friend, then when you visit Bob, it might tell you, okay, my friend and my neighbor is John, but you already picked up John. What you're doing is initializing an array or a set with all the visited nodes, so that when you need to pick up a guy, it's a computer. It doesn't know that you already picked up the guy. So when we need to pick up a new guy, we first check if it has already been picked up, or in graph theory words, if this node has already been visited. If this node has already been visited, then no need to pick it up again, and we just don't add it to the queue. We are going to add to the queue only the unvisited node. So we are basically picking up all our friends in order, and the way we do this with the algorithm is first we initialize a queue. We need to have an empty queue so that we can add all the neighbors. Then we add the start node. If the start node is you are the first guy who is going to the party, you add yourself into the queue. And then you initialize some kind of an array of each of the guys that you need to pick up to the party, and you mark them all as non-visited. And once you pick up any one of them, then you move ahead and mark them as visited, because you already picked them up to the party. Let's hope it's a great party after all the effort that we are doing. And then you start the loop. And the loop is now simply like a dump loop. It's looking at the queue, and it's telling itself, what is the next node, or what is the next guy that I need to pick up? The next guy that I need to pick up is John. Okay, let's pick him up. And once I pick him up, okay, I first need to check whether it has already picked up, whether it's already in the queue. If this guy is already in the queue, then I don't need to bother at all. It's already it's already marked as visited, okay? And then once I pick up a guy, then I add all its neighbors to the queue. This is my loop. So it's like two parts. In the first part, you initialize a queue, empty queue. You put the first guy in the queue, and then you start the loop. Now the loop is going to dumbly look at the queue and say, for each item in the queue, I'm going to check. I'm going to pick it up, and then I'm going to add new items to the queue if they were not yet visited. If they were not yet visited, then I'm going to pick it up. Okay, then this is the basic algorithm of the DFS. With that, you have basically finished the DFS. What you need to know is that you need a queue. You need to visit items. Anytime you have a new neighbor to visit, don't visit it immediately, because otherwise you will end up with DFS, and we're trying to have a BFS. So you add it to the queue to remember, I'm the bus driver, I need to pick up this guy, so I'm just adding it to the queue. And when the queue when this guy reaches the head of the queue and the D queue, I'm going to pick this guy up. And I'm going to mark that, I'm going to remember in another notebook that I already picked up this guy, so I won't need to pick it up again. And now, let's say once you picked up someone, you want to know what is the path from, let's say, Elton. Let's say we have two guys. Okay, let's say we have Elton, and the first guy, the bus started up from John, and we want to know the path from John to Elton. So we said that BFS is a basic algorithm. So if we started with John and we want to know the path to Elton, then the thing that we could do is to add an array. We said that the BFS is a basic building block algorithm. Now let's see how this basic building block algorithm solves the problem of what is the path from node A to node B. Okay, so once you ran all the BFS, if you have an auxiliary, please add an auxiliary an array where each item in the array is a node, and from each node just mark what was the previous node. For example, if I reached Elton and I reached Elton through Jenny, then I'm marking the node of Elton as having a previous node of Jenny. Okay, so I just have an array of all the nodes, and from each node I am marking what was the previous node that I got to him. And in this way, each node, and this is each node holds the previous node. So BFS is the basic building block algorithm, and I have an auxiliary array while I'm building this BFS, and this auxiliary array holds the previous node. And the previous node in this auxiliary array will allow us to know the path from one node to another. Because once I know the previous node for each node, let's say you know the previous node for Elton, you know the previous node for Jenny, you know the previous node for David, then if you know the previous node for each of the nodes, then you can build this path, but you need just to reverse it at the end. So to sum it up, the BFS algorithm is a great basic algorithm. You need to use a queue. For each node that you visit, you first need to check if you already visited it. If you already visited it and nothing to do, you just hold an auxiliary. This is a repeating theme in algorithms, that you hold auxiliary arrays and auxiliary data structure where you remember some stuff, because this is the same thing that you do in your mind or in papers. You write some auxiliary stuff. Same thing the algorithm needs to do. It's not better than your mind. It also needs to remember some stuff in auxiliary arrays. So you remember all the nodes that you have visited. Once you visit a node, you mark it as visited. If it's not visited, then you add it as a neighbor, you add it to the auxiliary queue array. Once you added it to the auxiliary queue array, then you start pulling out nodes out of the array and you visit each of them. And in this way you traversed all the graph with BFS. So thank you for listening. I think this was interesting and we'll continue the next time. See you then.